Math with Oscar class. That's my dad.
In section 1.1 in the textbook, there is a very large number of definitions that you need to know. What we're going to do is go through each of these terms one by one and establish a definition and a picture to go with them. Your notes should show term, definition, and sketch. Let's begin. When we start to look at the actual definitions, we're going to pick up here with undefined terms, which means we're actually going to define things that are not defined. Don't think about it too hard, it will start to hurt. The undefined terms would be defined as a basic figure that is not defined in terms of other figures. Now that hand you see popping in, that's my assistant. He's going to lean in so you can see him. There we go. So in other words, an undefined term is something that we don't reference to other things. For example, you might define a ball as a type of sphere. Right, Xander? You can scoot in. Or how would you describe a cat? What words would you use to describe what a cat looks like?
Furry
Okay.
and really cute.
And cute. Well, that's not much of a definition if you don't know what fur is, right?
Yeah.
And you know what fur is. What's fur?
Fur is on many animals,
Okay.
like on tigers and lions and cats.
It's like a type of hair.
Yeah.
Right. So as you drill down in the definition, there are terms that keep being used. The undefined terms, on the other hand, are terms that they just are, that everything in geometry builds off of. Now, we have three undefined terms in geometry. They are, and you do need to know these three. Point. So can you draw me a point right here, Xander?
Oh, like an arrow?
Draw me a point.
I'm going to do an arrow.
Okay.
Which way should I point it?
Wherever you want to. It's your picture.
I'm going to point it.
Okay. Now that's Xander's version of a point. In geometry, the point looks like a dot. I like Xander's better. It's a little more interesting, but that's the one you should know. I'm going to draw a line. That's the second undefined term. Can you draw me a line?
Yes.
Oh, there goes his line. Good news, that's kind of what my line would look like. And then we have plane. All right, Xander, draw away. So, in geometry,
What's plane look like?
draw a plane. You know what planes look like.
Oh, I can plane in the air.
Sure. So, an undefined term is a basic figure that is not defined in terms of other figures, and in geometry, they are point, line, and plane. You need to know that list. What we'll do later is we'll actually then define each of these terms, so just hang on. That's your plane?
That's a propeller.
Oh, the propeller. Okay, then we need some wings.
Make it a line.
That's the wing.
Yep.
Okay.
And then these little legs, like those, are the wheels.
All right.
And it's going to have its antenna.
An antenna.
To help
Okay.
to know where it's going.
Let's actually talk about the real geometry definitions of point, line, and plane. But remember, when we say undefined term, those three words need to come in mind, right?
Yep.
All right, say goodnight.
Good night.
The first undefined term, as we said, is point. So, the definition of point, technically, not Xander's point, but the geometry point, is that it names a location and has no thickness. So it's a geometric object that identifies a spot. So we represent it with a single dot, and we use a capital letter to name it. So there's the point A, here's the point B, here's the point Q. Those are all places in space that receive a letter name. So this particular spot in space, that location, is called point Q. The second undefined term is line. It refers to a straight path that has no thickness and extends forever. Now there's that idea of thickness again. there's no width. A point, here's the point P, is simply a single dot in space, an infinitely small dot. I could put another dot right next to it, call it point Q, and they're different positions in space. I can move over 1 nanometer, and I'm at a new point. A line then connects two of those points with a straight path. It has no thickness. If I were to really draw it properly, I'd have to use a super sharp marker. Then the line would be so thin you wouldn't be able to see it because it's that tiny. Even the line of a molecule is too thick for a geometric line. So we use this as our representation of it. You'll notice that there are arrows that indicate that it indicates that it extends forever. Now, lines can be named either by picking two letters from them, 2 points, P and Q, and drawing a double arrow over the top. Or we can assign a single letter name to it. So here's another line. Say we attach the letter L to it. This would then be referred to as line L. The third undefined term is plane. Now, that's not the plane in the sense Xander was thinking of. It's a plane in terms of a flat surface. For example, we have the plane of the marker board I'm working with here. We have the plane of the table that the iPad is currently sitting on. We have the plane of the floor, the plane of the wall behind me. All of these are flat surfaces that act as good models for the plane that we refer to in geometry. Now, what's important to know is the plane has no thickness. We only refer to that surface, not how tall it is. So the plane of the table is different than the plane of the bottom edge of the table because they're different planes. One's about an inch below the other. The marker board has thickness to it. So there's the plane which is the front and the plane which is the back. When we draw these, we're going to draw them generally as a parallelogram to represent the idea that it's a three-dimensional object drawn on a two-dimensional surface. Planes can be identified using a very bold print, cursive-like letter type of script. So we might call that plane R. Or if you pick 3 points that are not in a line together, A, B, and C, we can refer to this as plane ABC. The fact of the matter, though, is you must pick 3 points that are distinct. They cannot be in a line together if that's how you name your plane. If they line up, you haven't identified a specific plane. We'll talk more about that when we get into the postulates and theorems for the chapter. Next up, we have the terms collinear and coplanar. Collinear refers to points that lie on a single line. So points on a line. Coplanar refer to points on a common plane. Again, you see the term planar and the word plane. Linear and line. So if I were to draw points that are collinear, I would draw 3 points that are on the same line. If I wanted to draw points that were non-collinear, there would be points that are not collinear because no one line contains all 3 points. When I talk about coplanar, again, here's my plane, and here would be some points together on that plane. It is possible to have 3 points not on a plane together. Sorry, 4 points not on a plane together. 3 points always will be. It's also possible for points not to be on planes we might think of. For example, maybe I have a flat surface. And you might say, are those 3 points coplanar? These two are on the table and this one is above it. They really are, because I can draw another plane that contains them. If you can take a flat surface and connect all the dots with it, you call it coplanar, meaning they share some surface. Always be willing to think about different ways you can orient a flat surface to connect those dots. Same idea with collinear. Can you find a way to draw a single straight line that connects those dots? A segment will be our next object. Now notice in this I reference point and line as part of the definition. I'm building my definitions off previous defined terms. A segment is part of a line consisting of 2 points and the points between them. So actually, we'll change that to line between them. It really depends on which textbook you work out of, what word they use. So, if here's a line, call it line L, and on it I mark off point X and point Y. A line segment would be this point, this stretch of line, up to that point over there. I would then call this the segment XY, and I would put a single bar over the top to show that was just a segment. In contrast, the whole line, the part that extends forever, I would call line XY, because it extends forever. Line, segment, no arrows, arrows. That's how you separate segments, or things that are finite, from lines, things that are infinite. Endpoint, we referenced when we talked about segment. This refers to a point at the end of a segment or the starting point of a ray. Now we'll define ray in a moment. But when we talk about a segment, so here's a point, here's part of the line between them. The segment would refer to segment P, Q. That means that this right here, point P, would be the end point, as would Q. Segments have 2 endpoints. They're usually part of its name. That's so you know where the segment starts and stops. The next term is ray. A ray is a part of a line that starts at an endpoint and continues forever in one direction. An easy way to think about ray is it's a half of a line. Remember I said that point, line, and plane are undefined terms. We simply accept them as they are. But when it comes to these other terms like ray, you can see that we're referencing point and we're referencing line as most of our definition. You take a line, put a point on it, and then erase the part you don't need. Now you have a ray. And let's say this ray is called ray A, B. So A is one endpoint, B is the other endpoint. We would then state its name as AB. Capital A for the starting point, B for the direction we're going, and a single arrow to indicate what direction we're headed.